My name is Maciej Mensfeld. I'm a software engineer. I've been programming for 15 years. I'm a creator of framework called C.R.A.P that makes Ruby work together with Kafka, and a founder of Koritsu, a small startup that aims to make code quality better in companies. You can find me on Twitter. If you have any questions, you can just mail me. I run a blog about programming as well. Today we'll talk about quality, what is it, how we can make it better, how we can make it worse. We have half an hour, yeah. And what will happen if we want, as an industry, focus on quality more? So the first question is, what is code quality? Everyone wants to work with software that is well built. How many of you program? Please raise your hands if you program. Okay, please raise your hands if you don't. Yeah, 2 more people than in Wrocław. In Wrocław was one lady that wasn't a programmer. So we have 4 people here, non-programming, which is, I don't know if it's good or bad, but it's kind of interesting. So from my experience, most of programmers want to have good software of good quality, but it doesn't mean that they want to build quality software. They just want to have it. They just want to get into companies that already have well-built software of a high quality. And most of the time when I speak with people and I ask them what is quality itself, they cannot answer. It's just like, it is a quality. It's just there, like many other things. And I ask myself the same question. How can I define quality? And can I develop software of good quality without understanding what it is? And to get a grasp of what the quality is, I've started to look into books, and I found this really good philosophical book called Zen and the Art of Motorcycle Maintenance by Robert Pirsig. It's a really old book that is not about motorcycles, not about programming, but it's about both of them. And I really recommend this book because it's a philosophical book about quality itself. Robert Pirsig brought this concept that, which wasn't new, he just put it into words, that quality is care. When we care about what we do, it always comes with the quality. But there's a question why even care at all. We can just, tapa, 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 tapa. And most of the time it works, right? We follow the easiest road. We just do stuff on demand when it is needed without thinking too much, especially when business is forcing us to do things quickly, to deliver, to do more and more and more in the same time frame. And the answer is really straightforward. We need to care about the quality because we interpret programs. We do it on an everyday basis, and machines just do this from time to time. So we do it for ourselves, not for the machines. They don't care about the quality as long as it works. Well, it works. And to start measuring quality, we can always get a new team, put it onto our project, and count the number of WTFs per second or per minute. And this is the basic way to measure the code quality. But to put it into a business perspective, IBM made a research that proved that a production bug might cost 100 times more in terms of cost of fixing than the same bug being found at the design level. And it is tremendous amount of money, and probably since most of you program, you feel it, right? That if you put something on production and then if you try to fix it, it will probably create more bugs, pressure, you waste your time, a lot of other people waste time, help desk, things like that. And 80% of bugs can be eliminated at the design or static analysis level. Also, there is this theory that broken window encourages people to do bad things. There is a higher probability that you will steal something when you see that the window is broken and that things are just lying there, or that other people are just stealing stuff. And exactly the same principle works for software development. If you get into a project and it is badly written, despite the fact that you might be excellent programmers, you won't care at all. Because why would you? 20 people before you didn't care and it works, so there is no point of caring. But there is a point. And I will give you a few examples of how mistakes can cost money and a few other things. The first example is really nice. It's a Toyota and Lexus car that had a small malfunction. It didn't stop. That's all. Like you could drive it until you decided to stop. And few people died. And it turned out after a lot of research, they had to get all the cars back, fix them. They replaced some of the hardware parts. But in the end, after investigation, they went down to a software bug. And the really funny thing is that NASA was involved in this bug research, and they proved that a single byte, a single bit overflip could cause it. So they just didn't test it well. They just put it on production, and I wouldn't buy a car that would not stop. A lot of people did. There is Knight's Capital Group that didn't test enough their deployment system, and what happened is that one of the servers had an old software version, and the rest of the infrastructure had the new version. And the old one started to do a biddings on the trade market and basically play with the new version. So it would buy stuff and sell it to itself, and they lost $500 million almost because of the deployment malfunctions. There's a Citigroup. It happened a few months ago. Many years ago, they migrated an old system to a new infrastructure. They didn't test it. They didn't care about some of the bugs, and 8 years later, here we are, $7 million of fines from US Security and Exchange Commission. My favorite, Orion 5. It is a space rocket. They had an Orion 4, and what they did, they just upgraded engine. There's a bit more behind it, but they upgraded engine and they decided that, well, it worked for Orion 4, so it should work for Orion 5. Well, it didn't. So this is a interesting example that if you upgrade your hardware, run the tests. And probably the saddest example, C.R.A.P 25. This is one of the ways to treat cancer. And one of the ladies that was handling the setup was working too fast. And the way she just, memorized what she has to do, and she was doing this so fast that it created a race condition, overflow exception, and the dose of radiation was so big that it basically fried some people from the inside. And luckily, more and more people are aware that quality in software is as important as quality in hardware. And the quality market is growing. It's getting bigger and bigger, which is really, really good. there's being a hype, slowly. You're here, so it seems that it's getting better. About quality, developers care. Mostly the ones that mature, they don't want to do crappy software anymore. I've met some people that when they decide to switch jobs, they always want to sign NDAs and review the code before they decide whether or not it's a good idea to work with a particular company. And I find it really amazing, and it's really good. But what people do when they want to understand quality, what can we do to decide whether or not a given code is good or bad? And there are some metrics that can help us. Obviously, code coverage, methods, and the code complexity. Documentation, no one likes to make it, but it's a really good factor as well. Code duplication, project size, method size, things like that. And the structure itself, because quite often structure is more important than the code itself, because based on the structure you can see the overall image of people behind the code. Who designed it? Was the code designed with some sort of idea, or was it just tapa? Patterns and code smells. Sometimes you just see a code and it just doesn't feel right. You want to fix it, and after a few days you just increment the documentation that says that if you tried and you failed, just increment the counter. And you have serious problems when you have in your projects unnecessary complexity, misleading comments, long classes, poor naming, code that's not being used at all. And when you have design pattern overuse, it's also really bad. And a tight coupling. If you can't change a single part of your system without breaking many other that should be independent, yeah, you're screwed. But the really sad thing for me is that there are no silver bullets. A lot of depends on the type of the project, size, people behind it, development methodology, and many other factors, which is really interesting because based on my experience, waterfall methodologies tend to produce better quality code, mostly because programmers know exactly what they need to deliver. With Agile in startups, they pivot quite often, so programmers tend to design as flexible code base as it can be, so because they think that it will be easier to change it in the future. There's the coverage. Probably there are some people here that aim to have 100% code coverage always. It is really expensive if you do it on a scale. If you have like 100 projects underneath you, microservices, things like that, having 100% code coverage always as it's not worth doing most of the time. Complexity can be misleading as well, as I said. Sometimes it's not a measure, yeah?
You mentioned about the coverage. What do you mean by coverage?
Test code coverage.
Testing or whatever?
No, I mean automatic testing. Keeps falling. I'm not talking about the QA. I'm talking about the code testing. So it's a automatic tests, functional it can be black box as well, but functional unit testing, things like that. Documentation, you don't do it at all. I know that because we analyze documentation. People don't do it. They don't care about it. And it's true for code documentation and also technical specs. Most of the small companies don't have technical writers. They don't do docs at all, as long as they are not forced to. And no one measures quality of the documentation. Duplication can be misleading because it does not tell you nothing, to be honest. Sometimes duplication is really, really good because it allows you to have code that is not tightly coupled. Lines of code, no, don't measure it. Or if you measure it, don't work based on it, because then you'll try to have as many new lines as you can design to prove to your boss that you're a better programmer than your friend. And it's totally opposite most of the time. And as I said earlier, structure is really important. If you decide to work with a software, first look at it as its structure. Keep in mind that people change patterns, people change jobs, and jobs change people, which means that programmers don't have the same quality, performance, or any other metric through the whole project life cycle. They can be slow at the beginning, and then they can get better, or the other way around, and it's worth measuring it. And this is exactly the point. Always keep in mind that the context is probably the king. It's the most important thing if you decide to measure quality. Try to have as many metrics and try to correlate them, provide a context to it. And here's a really nice example. This is just a chart with number of offenses of many types from a software across a year. And technically, if you would look at it, we started from a certain level, and now we have almost the same level of number of offenses. But what does it tell us? At the first, you would say that it tells us that we have the same quality as the one that we started. But if you correlate it with the number of bytes of code, then the picture is totally different. This software is way better now than it was because it's 10 times bigger than it used to be. We have 10 times more bytes of code than we used to have. We have 10 times less problems in the code, despite the fact that we have exactly the same number of offenses. Keep in mind that people don't work in isolation. Evaluate their work as a team members, evaluate teams. Remember that people quite often, especially with microservices, work across applications. And if you look into how they work with certain applications, you can figure out which are bad. If you have really good people that 90% of time work with design good systems, and then you put them into smaller teams and with a different project, and then they don't do a good job, it might be an indicator of them being assigned to a project that is really, really bad. And you're a programmer, let's say you want to start doing something with the quality itself. You don't do it, let's say you have tests and the software, and you don't have anything at all related to the quality. So the hardest thing is to convince people that it is worth doing it. Programmers are lazy, and it's really good, but you need to have the right attitude to deliver good quality. First of all, if you rush, you won't care about it. If you don't care about it, you won't deliver quality. And it will work like that always. If you code too soon, you'll debug forever. Keep that in mind. Raise awareness. You need to have money to deliver quality. So business needs to understand that it is worth putting money into the quality development. Well, if you tell them that it's way more costly to fix bugs on production and you are able to prove it, you will get money and time to focus on quality as well. Business quite often is not aware that the quality should not be taken for granted. They just assume that since you're senior developer something, you always deliver the best quality, your work is always the best, and stuff like that. Try to convince them that it's also related to their expectations and their pressure on you guys. Automate things. There are many good tools and systems you can use to automate quality checks, to integrate it into your continuous integration systems. Keep an eye on code that needs to be refactored. If you don't have time to do it, just make your systems aware. Be able to track code you need to refactor. And if you have more and more code like that, there needs to be a moment when you need to sit down, shut down the feature development, and just focus on it. Clean the code as frequently as you can. During a code review with automates, however, make it a habit. Spend 5% of your work time cleaning the code, especially if you have a big project that will last for quite long. If you do it slowly, after a year or two, you'll get there. Don't compromise. If you compromise once, twice, you will do it forever. Do documentation, but explain why, not how. It's totally not worth explaining how, because I can read the code. If I have a method, I can see how it is implemented, but I may not be able to understand why you did this that way. And if you copy paste, please update the comments. Document any unexpected behaviors, any unique ways of designing things, because when you leave a company, someone else will come, and without this context, they will just try to replace it with something that they think it's much easier and much better. Justify any violation of good programming habits. And if you have problem and 5 your teammates had the same problem, fix it. Don't make comments like, please increment this counter. Fail fast. Always fail fast. Raise exceptions. Don't ignore or hide them. If it's hard for you to track bugs in development, it will be much worse in production when you have, let's say, Docker, AWS, cloud, ephemeric containers. They're here now, but they won't be here in 5 minutes. It will be a nightmare to track hard bugs. And never modify exception stack. Don't catch bugs and replace them with re-rising other types of exceptions, because then you lose the core information about the exception itself. Don't fix stuff if it works. Use Git effort. It's a really simple tool that will tell you how often you change parts of your system, and focus on parts that you change the most frequently. It is totally not worth fixing stuff that works and that is not going to be changed in, I don't know, upcoming 2 years. If you have parts of system that are changed really frequently, test them well, document them well, make their quality good, and then you will save a lot of time. And obviously perform code review, and perform it not with yourself. When you end up with a bit of automation, you can use C.R.A.P metrics. It's a really good way to analyze and predict cost of maintenance of software. This is a simple formula. You can Google it, or I'll give you slides. It basically correlates the method's complexity with their code coverage. And based on this number, you can decide whether or not your code will be maintainable. If the score is above 31, you won't be able to maintain it. Either you need to put more effort into tests, or you need to rewrite the software itself so it will be less complex. And remember, the best code is no code at all. If you are able to deliver a product without delivering a code, well, there's nothing better than that. Outsource whatever you can: payments, deployment, infrastructure, file storage. Do the same with quality. There are many good quality tools for many languages. If you don't have the knowledge yet to do it yourself, you can always use both open source and paid solutions. Add a more context to them. Most of them don't add the bigger context of a company, of a microservices-based project. They always focus on a single repositories, but they're a good starting point. Monitor everything you can. You can use Git history as a source for data mining. With a simple project, 2 years, 5 people, you can generate up to 10 gigabytes of metadata on how people work, what types of mistakes they make, what is their code stability, and many other metrics. And you already have it on your GitHub accounts or Bitbucket, whatever. Just Git the shit out of it. Focus your code review on the business logic. If you will have enough automation, your code review can focus only on the business logic, not the styling, not the security. You can make sure that you understand the business and it works as expected. Other context, and remember that we're all humans. Programmers tend to think that they are their code, so sometimes you need to be really gentle during the code review. Don't follow the data blindly. Always try to interpret it and think about the context itself. Don't aim for the best quality ever, because the quality itself is always a bit subjective. And the last thing, if we fail, we're in Warsaw, so for people that don't know, this is the capital of Poland. The government will regulate us, and it's already happening. A few weeks ago, a guy that is related to the government approached me and asked whether or not I would like to be on a board that would advise the government to enforce code quality on all the software that will be ordered by the government. And I don't want to end up in a place where the architects are now, that you can do a software up until a certain size, because it would regulate all the things. You need to have this certificate to do this type of projects, blah blah blah. It would be terrible, but it will happen if we as an industry are not able to prove that we can take care of ourselves. Do we have more time? Która jest godzina? Okay, so I should probably stop now. I had a few extra slides, but I don't have more time, so thank you.